the shop, and this the 6th episode of making the MAXI CNC Router. So today's video we are going to be manufacturing all the parts needed to assemble the Z axes and hopefully mount a very heavy, may not look it, but it weighs about it's about 12 kilos, 2.2 kilowatt or 3 horsepower CNC router spindle on the head. So what I've decided to do is actually make this mounting plate here out of steel. I'm going to be using a 6mm, just a shade over 1/4 of an inch steel plate, rather than aluminium, because I would, to get the same rigidity, I would have had to have used either 10 or 12mm thickness of aluminium plate. And you know, there's two that's going to have to go on here. There's one mounting plate here, then a mounting plate for the motor itself. So that would have, you know, given me, you know, another inch plus. I think this is 35mm and this is 35mm. You know, the motor would have been stuck out here somewhere. So in an effort to take the center of this spindle closer into the gantry, I'm going to use steel. I'm going to save ½ an inch, you know, 13mm. So that's what I've decided to do, and it's about probably 1/3 of the cost as well. Not that the cost of that is worrying me. The main aim of it is to get the spindle in closer to the gantry for the minimum of extra weight. Now I have seen people, you know, use sort of 10mm or 12mm steel plate to go on here. I mean, that's a bit over the top. You know, the most this is ever going to machine is aluminium or brass. Other than that, it's going to be wood. And a 12mm plate, you know, nearly ½ inch steel plate to hold one of these, that's really getting to the ridiculous stage. It doesn't need it. So I'm going to get on now, start measuring out, marking out, cutting and drilling the parts necessary to mount this. Okay, so this is the part of the build, the Z-axis. This is where I suppose the most complex part of making a CNC router, because this is the plate. If you remember earlier in the video I said, oh, I'm making this of steel. In this case it's 6mm steel instead of 10 or 12mm aluminium, and the reason for that is going to become apparent right now. Now, I wanted to use a 20mm screw, which there it is, and that's where it's going to fit. And of course this is a 20mm linear guide rail, square linear guide rail. So there's going to be one there and one there. And the problem arises is the plate, which is again is going to be steel, which is going to be mounted on here, on these linear bearings, that the spindle mounts onto, there is a gap of 16mm. Now, even if I'd have used a 12mm screw, there still would have been a discrepancy of about 5mm. So to get over this problem, what I'm going to do is I have 10mm here of aluminium, which I'm going to make a 10mm shim to go underneath each rail, so that pushes the rail 10mm forward. And then I've got some 6mm plate aluminium that I'm going to cut and drill and make a shim, as it were, to go on top of these linear bearings. So then that it's actually the distance between here and here, the underside, the distance between here and here is 15.25mm. So if I use a 10mm and a 6mm by putting 10mm underneath the rails to shim those out, and then a 6mm shim plate on here, that gives me 16mm, which gives me the clearance that I require. So I hope you can understand that there's no going past it. You know, it has to be done. Now, if I'd have used aluminium plate of 10 or 12mm here, and again another 10 or 12mm thick aluminium plate to go on here to mount the spindle, that would have taken me out, you know, double the amount of what the thickness of this plate is. In this case, it would have taken me out another 12mm further on out. So I hope you can understand that. So nothing for it but to I've actually started marking out. I've marked out this already, which is what you can see drawn on here. I'm just going to drill these, countersink them, and I got countersink hex bolts, and we'll mount that up first, make sure that's all okay. Then I can start making the shim plate material, and probably then mount this onto here, because you can see too that where these holes are going to be, you have to juggle things around and fit, you know, this. So this is just going to be about there. That's okay, that doesn't really matter. These holes are going to go just slightly north of the bottom holes here. You know, there's going to be a head underneath here. Okay, but I can jiggle that around to bypass the head of these, and these rails are going to lie just there. So I'm going to miss, you know, you've got to sort of miss the heads and bolts underneath them as well. You know, that's why they're countersunk as well. So, you know, there's no real problem there. It's just all going to be worked out. Okay, so let's get drilling, I suppose. Okay, when you get this far, just make sure that the first thing to make sure is that your Z-axis plate is absolutely square with the bed. This isn't the actual bed. This is a spare piece of sheet that I had, but it represents the bed and it is square to the gantry. So you need to get this square to the bed. Okay, so your Z axis carriage goes vertically up and down 90 degrees to the bed and the x-axis or gantry. Now you will notice that I have elongated a couple of screw holes here to get this perfectly, because I actually drilled it size for size. In other words, 5mm bolt, 5mm clearance hole, and also 10mm for the head, because it needs to be sunk into the material. And when I put it on there, it was cocked over, only very, very, very slightly. But I couldn't adjust that anywhere else other than elongate some of these holes, so I could actually turn this and tighten it down. You know, you will need to make adjustments like that. The same as I did with the gantry uprights here. You know, I filed the bottom of the mount by 1 millimeter to be able to get the gantry absolutely square to the bed and the y-axis. So you will have to do this. It's called fettling. And another thing you need to do is once you've got this square, okay, is start this end. Alright, bring your carriage all the way up, tighten up these, okay, and bring the cartridge down a ways, tighten up a couple here, then here, and then right at the very end. And then make sure all of them are tight. And make sure that your carriage slides from one side, the full one side to the other, and not feel any binding at all. It should be fairly, you know, the same amount of pressure put on to move the carriage on the entire length of the run. So you do all that before you go to the next stage of, you know, marking this out, setting the, you know, and drilling the holes for this, and the rails and what have you. So you get all this right first, and you get this right first. Because if you make a bad mistake here, you know, it's a lot of work that's going to go into this plate, you know, and you're going to be wasting your time. Okay, so when you get to this stage, just I'm advising you to you know, sort of first of all make sure this is square to the bed, then go and tighten up from one end, working from one end all the way through, tighten these up and make sure that it's the same amount of effort then all the way along the x-axis or the gantry, and then, you know, then it'll be good to continue. So my next job is to, now I know this is correct, so my next job is to put this in place, drill it, and tap the thread into this and mount it. Then mount the rails on top of the spaces that I have to make. So that's the next job. So once you've got one rail accurately screwed on to your Z-axis main mounting plate, I'm going to show you the way I put this together, or assemble this ready for drilling then, very accurately, but it's very accurately. And it's quite crucial because in this area it's very busy. You know, there's a lot going on here that has to be absolutely correct within a couple of thousandths of an inch or tenths of millimeters, even 20ths of millimeters. Now, the way I've developed to do this type of thing is really just with two steel rules. Now these are exactly 1 millimeter or 40 thou. Okay, so, and you require the bearings on the rails to do this, and also the bearings on the ball screws. So you put one on there like that, you put it in the rough vicinity of where you want it. I'll bring the camera in for a better look for you. Okay, so you have your one steel rule there, which is 40 thou or 1 millimeter, and you get your bearing, your assembly, your Z-axis screw assembly. Okay, because you need to make sure that you have clearance between these bearings here and these bearing blocks here. This isn't really a problem, and you just get your other one that's assembled up, put here with a second rule, pop that in there and just push it up and get this in the correct position. So now all you need to do is clamp this down and mark these holes. Now I know there's 6 millimeter hole through here on the inside, so I just get a 6 millimeter drill and just do a center mark. Just mark the steel underneath, then take everything off and drill and tap it, and you know this is exactly right. Now at the same time you can clamp this in place and do the two jobs at once. And again, 6 millimeter drill, just mark where the holes are going to go, and then drill and tap those. These are 6 millimeter M6s, and these are M5s. Okay, don't go putting the wrong size hole in there. So really, a complex job like this you can make very easy by just lining this one up first, parallel with this edge, and then using two rules of equal sort of dimensions, in this case 40 thou or 1 millimeter, and just placing the items in place and clamping them. So you need to clamp these down before you spot them. It's called spotting. Alright, it's a lot easier than marking out. It's a lot accurate than marking out, because the holes are the actual holes that I did on the underside of here, although I accurately marked them out, when I came to put it on there, they were a millimeter or so out. In a couple were a millimeter out, and I had to elongate the holes to get it to fit perfectly. So that's what we're going to do next. Spot these holes, and then drill them and tap them.